Hello everyone, welcome back to my channel. So today we will be discussing about the background that we need for scheduling algorithms. So first thing that we need to know is about the different queues. So what are the different queues that we would be needing in this? So first of all, we have the ready queue that we already talked about, wherein we need to move our process from ready state to running state or ready state to the other state. So that's a ready queue. Then after a ready queue, we have a job queue. So what is a job queue? So a job queue is basically a queue in which we have jobs that want to be created as a process. And then finally we have an IO queue. So we also learned about this in the state models. In that we saw that some process might be waiting for IO or might be waiting after IO to move to the ready state or running state. So that sort of a queue in which we have such processes that need IO is known as an IO queue. Then after that, two terms that we need to know about are short-term scheduler and dispatcher. So about short-term scheduler, we studied about in one of the previous videos that the role of a short-term scheduler is to pick one process from the ready queue. And then what is a dispatcher? So once short-term scheduler has picked one process from a particular queue, that is from the ready queue, then dispatcher comes into the role where it does the context switching. Next, we also need to understand that the scheduling algorithms that we would be using would be valid only for short-term schedulers or for the jobs ready in the queue. Now, let's understand when is a job picked by the scheduler. So there are 4 different cases possible. So the first one is when some other process moves from running to waiting. So when some other process moves from running to waiting. And after that, the second one is when some other process moves from running to ready. So when some other process moves from running to ready. Then the third one is when a new or existing process moves to ready state. And finally, the last one is quite obvious one, that is when a process terminates. So these are the 4 cases in which a job gets picked by the scheduler, among which these 2 are preemptive ones. Now, what do we mean by preemptive ones? So in this, what happens basically is that we need to preempt the existing process on the scheduler, then we can do this. So that's why it's preemptive, and when we'll discuss the preemptive scheduling algorithms, we'll understand the meaning of preemptive in more detail. Now, next point that we need to study for this would be the different times in scheduling algorithms. So what are the different times in scheduling algorithms? So first of all, the one which we have is arrival time. So arrival time, let's talk about all these times for P0 process in this one. We can see that here we have a process block made where we have different times given to the different processes. So what would be the arrival time for P0? It's the time at which it enters the CPU. So here we can see that it's 1. So the arrival time for P0 would be 1. Then completion time. So when do we see that P0 is completed? So that's at 6. So the completion time would be 6. Now burst time is basically the time taken by the process on the CPU. So here we can see that in the first section it takes 3 minus 1 is equal to 2 time units, and in the second it takes 6 minus 5 is equal to 1. So 2 plus 1 gets 3. So the burst time for P0 would be 3. Now what is turnaround time? So turnaround time is basically the time difference between the completion time and arrival time. That's the time that it entered the CPU and the time that it exited. So basically the time difference between these. So here what we get would be 6 minus 1 is equal to 5. Now waiting time. So waiting time is the time that the process had to wait after it entered the CPU. So we can see here that when P1 entered in between, that is from 3 to 5, the process P0 had to wait, and that was 5 minus 3 is equal to 2. Now response time is basically the time at which the time difference of the time it got allocated to the CPU with the time that it entered. So here we can see that it started exactly at the same moment, so that would be 0. Now we can discuss the formulas for some of them. Like for turnaround time, it would be completion time minus the arrival time. For waiting time, the formula would be the turnaround time minus the burst time. So that's it about the different times in scheduling algorithms. Now before we move on to the scheduling algorithms, we also need to understand what are the various goals of a particular scheduling algorithm. So the goals of a scheduling algorithm are as listed below. So first one is maximum CPU utilization. Then the second one is maximum throughput. So what is basically throughput? It's the number of jobs finished per unit time. Then we have minimum turnaround time, minimum waiting time, minimum response time, and a fair CPU allocation so that there exists no starvation. Now what we see that these are the goals of a scheduling algorithm, but we don't talk about these for particular processes, rather we talk about the average for all processes. So basically the average turnaround time should be minimum, average waiting time should be minimum, average response time should be minimum. But what we'll see when we'll discuss the scheduling algorithms is that none of the scheduling algorithms can achieve all of these points. It will have to sacrifice on at least one of those points. So that's it for the background of scheduling algorithm. Now we'll be studying the various scheduling algorithms. Thank you.